So we will see in our official presentation today, which we'll go back to pretty soon. There is a demonstration that silly attempts to modify reference fail because anytime you're trying to use reference, it is simply being used as a synonym to an already existing object. Once initialized, for the life cycle of this reference, it just stuck with, it's like another name for this integer. In fact, let me demonstrate it this way. I can create an integer reference. I don't know, I could like type it like this and say ref1 equals 1. So I can create references, standalone references, just like I'm able to create standalone integer, pointer 1, right? This time I need to take address of an integer. But with references, I don't have to. I need just to provide an object which I would like to refer to. And from this point on, ref1 becomes just another name for 1. Now, this can be practical in cases such as, for example, if I have some sort of container, right? And in that container, I have some kind of subcontainer. And then I have another subcontainer. Blah, 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 blah. And I have something else. And down there, I have integer x, right? So my choices are either to use this crazy expression to get to an integer inside the container, subcontainer, another subcontainer, and something else, and finally some place in there. Instead, I can just create a synonym to this and basically use a simplified version of this real thing, which is someplace else, right? So standalone references have the purpose like that. But most of the time, you will see integers, by the way, also as pointers, that are primarily arguments in a function. So function is defined with the parameters of the function being indirect parameters. So instead of copying objects, we're trying to refer to them indirectly. And of course, both pointer and reference are examples of that indirect access to the original objects 1 and 2. So anyway, so these are some demonstrations. But again, if I go back to just my standalone reference like this, just remember, when creating a reference, this ampersand is the type modifier, and it's pronounced as ref1 is a reference to an integer, and ptr1 is a pointer to an integer. And of course, initializing pointer is very much like a standalone variable. It stores an address of another object. Therefore, you have to be explicit and say, okay, I have an object, but I'm taking an address of it, and I'm giving it to you to be pointing to it. With references, you only need the object itself and say, okay, I want to have a synonym to this one. That's not enough that I have one. I also want to use ref1. And anytime I use ref1 or 1, it's undistinguishable. Both will be behaving exactly the same way. Right? So it's just another name for 1, which was officially declared earlier on. Which is right here kind of silly idea, but over here it's not so silly anymore. Well, one reason to do this so that this syntax is greatly simplified. We don't have to take addresses. However, there could be some disadvantage that, this approach may also be criticized by some people, saying that, hey, when I have a swap, which actually modifies objects in my code indirectly, so by taking addresses of them in this first version of the function swap, it gave me a reminder that in order to use swap, I need to take address of a variable and remind myself that I'm actually not passing the object by copying it into the function, but I'm passing an address of it. So therefore, this can be modified inside. And swap, of course, is a pretty heavily suggesting that that's about to happen, right? So so sometimes people would say this is a better coding because it has this inherent reminder that things will be happening indirectly to these two things, 1 and 2. Whereas over here, who knows? Maybe, maybe not. There's no way to find out unless you find the function and examine and say, oh, by the way, it's still using an indirection and it's still accessing the original objects by doing the swap of 1 and 2. So both swaps will work just fine. So let's see. I may obviously remember other things as we move along. In the meanwhile, I already posted an update where I would like to quickly switch to linked data structures as we finish the topics with copy constructors and some other aspects, some other constructor-related business, which, by the way, heavily relies on references. But right now, just by the way, midterm exam is also posted. It's just another pointer quiz that you should be taking. And our official presentation today is going to still be the object life cycle. And we stopped, we mentioned the role of constructors, the role of destructors, some of the rules that we need to be aware of specific to destructors and constructors, something that we say chaining of constructors and destructors. And finally, we just came across this reference thing. So let's see what it says here. C++ reference is very much like a pointer because you know what? Of course, left and right here store addresses. But those little objects pretend to behave like integers by their design once initialized, past the point of their creation. By the way, a requirement is that references must be initialized. They cannot be created without something that can be used to initialize them. There's something I would like to show you, but in order not to forget, let me mark it here. I'd like to mention something before we move on off of this topic, because I may forget this. Okay, so syntax is just like using an object, and you can have references to objects, or you can have references to primitive data types. References always refer to something, but remember, with pointers we could set them to null, to like 0, and they will not be pointing to anything. We can change it. References can be reassigned to something else. So very strict rules on this type of indirection. Some really strict constraints on how to use them, and obviously they must be initialized. Initialization is required, is absolutely required. Okay, in case if you're using references. Function parameters we call implicit reference initialization, because right here, every time this function is invoked, you could pass other integers to the swap right here, and every time those left and right, those two will be initialized with something implicitly, but from this point of initialization they will behave exactly as integers. No need to dereference them. Okay, and there's no way to change them, and becomes an eternal synonym. And soon we will discover why is this helpful, why we think that this is something that really helps us out. So here's the swap example. We actually, in our code, we had 2 versions of swap. By the way, a reminder that this is called function overloading. We have two versions of functions, but the set of parameters is different. two pointers versus two references is different. So we have actually two functions, and they can be successfully called like this: swap and swap. The compiler will understand that this is going to use a reference version of it. This will be using the pointer version of swap. That's allowed, and it's called function overloading. Also supported in Java, in C# and other object-oriented languages. So of course C++ also does that.